Good day, especially to our instructor, Dr. Junel Mark D. Sarno. We are going to discuss the toxicology. So, what is toxicology? Toxicology it is a scientific study of poisons, their natures, properties, effects and detections, and treatment in case of poisoning. Toxicological examinations are requested in case of sudden and unexplained deaths. Collection of sample for toxicology examination like lungs, organs, kidneys, brains, and blood. Importance of toxicology is to verify if it is a case of poisoning, to be able to treat as the occasions demands, and to forward justice. What is poisons? Poisons it is a substance that when introduced into or absorbed by a living organism causes death or injuries. Poison is a substance capable to producing adverse effects on an individual under appropriate conditions. We have here the types of poisons. We have the true poisons is one that still poisons no matter how diluted it is. Example of this is hydrogen cyanide. Corrosive poison is it produces local destructions of tissues. Example is nitric acids, mercuric chloride acids, poisons used as herbicides, also commonly known as weed killers, are substances used to control undesired plants. Cumulative poisons is one that increase suddenly intensity of actions after gradually addition of it. Lead is a cumulative poisons, meaning once it is entered into the body, it accumulates in areas such as blood, kidneys, livers, and brains. Inhaling leads dust of fumes is the most common way to lead poisons occurs. Acute poisons or poisoning, one is in which there is prompt and marks disturbance of function or death within a certain period of time. Lastly is the chronic poisoning kind of poisons in which there is gradually this deteriorations of functions of tissues and may or may not result in death. We have here the evidence of poisoning. We have circumstantial or moral evidence is evidence deduced from occurrence of the fact or circumstances. Symptomatic evidence is include the symptoms observed during the poisoning. This is not conclusive because some disease may show similar symptoms such those of poisonings. We have the chemical evidence. This is evidence obtained by chemical analysis of the suspected substance or the vomit or secretion of the body. This alone is not reliable because the poisons may be decomposed or changed, or it may have been replaced after death. So we have the post-mortem evidence. This evidence is obtained from an examination of the tissue and the organs after death. There are many poisons, however, that do not produce characteristics findings. Also, the findings may be like those produced by disease. So we have the experimental evidence. It is obtained by administering the suspected substance to some living animal and observing the events of symptoms. This alone is also not conclusive because not tolerance may not be the same as in man. We have the four elements of poisoning. We have poison, the poison organism, the injury to the cells, and the symptoms and the signs of death.
And now the classification based on origin. Toxin. A harmful compound that is usually produced by living cells or organisms and is capable of causing disease or harm when introduced into the bodies and tissues. And now, let's proceed to the venom. Venom is injected via sting and bites. Venomous. Bites or stings. And also the poison. Poison is consumed, inhaled, or absorbed through skin. Poisonous. Plants, fungi, and also the amphibians and chemicals. Poisons. A toxin that enters the body by being swallowed, inhaled, or absorbed through the skin. And also the venom, a toxin that enters the bloodstream through injection or an injury. Classification based on origin. The vegetable. Poison, ivy, and gemsuid. Plants. And also the mineral, hydrochloric acid, and caustic alkali. Microbial, produced by microscopic organisms. And now this is the example bacteria and fungi. Synthetic manufactured by chemists such as drugs, pesticides, as well as chemical purified from natural sources such as metals from ores and solvents from gasoline. Classification according to acetone, physiological, irritants, caustic or irritating substances injure the mucous membranes of the mouth, throat, gastrointestinal tract, and lungs, causing pain, coughing, vomiting, and shortness of breath. Skin contact with toxins can cause various symptoms. For example, rashes, pain, and blistering. And example, bromine chloride and cotton and oil. And corrosives by direct contact chemically produces local destruction of tissues. And now, this is the sample. The neurotics, those that affect the central nervous system, like spinal neurotics, tetanics, a poison that acts on the spinal cord producing spasmodic or continuous contractions of muscles, resulting in stiffness of the parts to which they are attracted, like for example, strychnine and pyrotoxin.
The next issue that forensic toxicology had faced with mental-based poisoning was quantifying poison. It was no longer sufficient for a toxicologist to say that the amount of poison found was fatal without having numbers to back up the statement. In murder case in 1911, Dr. William Wilcox developed the first method for quantifying arsenic. Frederick Henry Seddon was arrested for poisoning Elizabeth Barrow to steal her assets. Scotland Yard authorized Wilcox to make some tests. He ran hundreds of weights tests for arsenic and then used his method to figure out how much arsenic was in each of poisoned woman's internal organ. He calculated the amounts via body weight in milligrams. His method was eventually refined over the years to the point of being able to detect the presence of arsenic down to the microgram, 1 million of a gram in a body of human and soil. A famous case that involved the quantization of poison was that Marie Besnard, known as the Black Widow of London. Besnard was accused of killing 12 people with arsenic, including her husband and her mother. The string of deaths stretched across 2 decades. From 1929 until 1949, Marie benefited in some manner from each of the murders, thus providing the prosecution with a motive. All of the bodies were exhumed and high levels of arsenic were found in each one. However, aside from the poison, the prosecution had only circumstantial evidence against Besnard. When the case went to trial, the defense attacked the lab technique of toxicologist Dr. George Berrand as careless. This caused significant sufficient doubt that a second toxicological investigation was requested from a group of 4 toxicologists. While this second investigation was being performed, the defense learned about the new theory. Through anaerobic bacteria, arsenic could enter the hair of a corpse from the ground. This meant that the prosecution's expert would now have approved that the arsenic in the bodies had not been introduced after burial. When complete, a second investigation also found significant levels of arsenic in the corpses. However, Grifton, one of the toxicologists, had been careless in his determination of arsenic in hair. The procedure required that the hair be subjected to radioactive for 26.5 hours. Grifton had only exposed it for 15 hours, thus again calling the result into question. A third investigation was performed by another group of toxicologists, but when they could not disprove the defense's new theory, Marie Besnard was acquitted on December 12, 1961. Not everyone had such a clever lawyer.
Toxicology is the scientific study of poisons and their effects on living organisms, encompassing various of disciplines such as chemistry, biochemistry, and pharmacology. In the context of criminal justice, toxicology plays a crucial role in investigations involving homicides, accidental deaths, and suicides. By identifying and analyzing foreign substances such as poisons, alcohol, and illegal drugs, scientists can provide vital evidence in legal cases. The historical roots of toxicology can be traced back to ancient societies, where knowledge of toxic substances was utilized for medicinal and lethal purposes. Forensic especially focuses on the detection and analysis of toxins related to criminal activities. Its application in the courtroom has evolved significantly, with early cases often relying sensory observations rather than scientific methods. Modern forensic toxicology employs rigorous testing of biological samples like blood and urine to uncover traces of harmful substances, aiding law enforcement in solving poisoning crimes. The complexity of poison detection remains a challenge, as symptoms of poisoning can easily be misdiagnosed. But overall, toxicology serves as a critical tool in bridging the gap between science and the legal system, enhancing the understanding and resolution of criminal cases involving toxic substances.